Why vitamin C is not a vitamin. Everyone's heard of vitamin C. It's arguably the world's most popular supplement, often marketed for its immune system boosting properties or skincare benefits in cosmetic products. We know it's something we need or else we die from scurvy, but not many actually know the huge range of functions of vitamin C in our body. Combine this with some other not as well known facts that I'll point out soon, turns out that vitamin C might not actually be a vitamin at all. But to make my case, we're going to have to dig in a little bit into the history of the discovery of vitamins. In 1912, after reading an article that people who ate brown rice were less vulnerable to beriberi, a disease caused by vitamin B1 deficiency, Polish biochemist Casimir Funk successfully isolated a substance that he believed was the cure for this disease and proposed the curing substance to be named vitamine, a combination of words vital and amine, meaning amine of life. In his landmark paper on vitamine theory, Funk proposed that there were at least 4 disease-preventative substances like this, which we now know as vitamins B1, B2, C, and D. They found out later that not all of them were amines, but the name stuck and the letter E was dropped. So what is a vitamin today? One definition is any of a group of organic compounds which are essential for normal growth and nutrition and are required in small quantities in the diet because they generally cannot be synthesized by the body. Vitamins can be divided into 2 groups: fat-soluble vitamins A, D, E, and K, and water-soluble vitamins C and B1, 2, 3, 5, 6, 7, 9, 12. Our bodies are only able to make vitamins B3 and D, and the rest have to come from external sources. The deadly disease scurvy and its cure from citrus fruits like lemons and oranges have been known for quite some time, and it was the search for this anti-scorbutic or anti-scurvy factor that drove the discovery of vitamin C by Hungarian biochemist Albert Szent-Györgyi in the 1930s, for which he won the Nobel Prize in Medicine. The chemical name ascorbic acid, meaning away from scurvy in Latin, was proposed, which explains why scurvy prevention is one of the first things that come to mind when mentioning vitamin C. But with what current research tells us, this mainly anti-scurvy view of vitamin C immensely undervalues its actual importance in regulating optimal health, because it is also on this basis of scurvy prevention that recommended daily intakes, RDA, were established at just 70 to 90 milligrams a day. We're often told that we don't store vitamin C in our bodies, but that doesn't seem to be true. The top 3 organs with the highest concentrations of vitamin C are 1. The brain, particularly the pituitary gland, 2. The adrenal glands above the kidneys, which produces stress hormones, and 3. The white blood cells of our immune system. Vitamin C is also found in our eyes, lungs, liver, pancreas, kidneys, heart, skeletal muscle, and reproductive organs, basically the whole body. All these organs have higher concentrations of vitamin C than in the blood plasma, which requires cellular energy to actively transport vitamin C from the blood into its tissues. It's not hard then to suggest that our bodies are doing this for good reason, and taking into account the fact that humans cannot make vitamin C ourselves, perhaps we do need much more than we realize. Almost all animals are able to produce vitamin C in their livers or kidneys, except primates, guinea pigs, most fish, and some bat and bird species. A goat weighing 70 kilograms, approximately 150 pounds, is estimated to produce around 13,000 milligrams of vitamin C per day, and that's when it's presumably healthy and unstressed. When exposed to stress, rats have been shown to increase production of vitamin C in their livers, which shows an important role in the stress response. But what about the animals that cannot produce vitamin C, like us primates? Based on its diet of fruit and leaves, a 7 kg howler monkey is estimated to consume 616 milligrams of vitamin C per day, an equivalent of 6,000 milligrams daily if we were to extrapolate this to a 70 kg human. Gorillas similarly take in an estimated daily dose of 4,000 milligrams of vitamin C from their diets. The RDA for humans is currently 70 to 90 milligrams, and we eat nowhere near the amount of fruits and vegetables compared to these primates. But why is vitamin C found in pretty much the entire body? Vitamin C is a cofactor for 15 enzymes which lead directly and indirectly to beneficial effects on tissue formation or wound healing, mood and energy, stress responses, appetite, the immune system, and epigenetic regulation, meaning gene-regulating mechanisms. It is also a water-soluble antioxidant, which enables it to reach far more areas to protect your cells from damage by excess free radicals compared to a fat-soluble antioxidant, since our bodies are 60% water. There is mounting evidence now that the imbalance of too much free radicals, also known as oxidative stress, is a major contributing factor to most chronic and degenerative diseases such as heart disease, kidney disease, diabetes, Alzheimer's, dementia, cancer, cataracts, and autoimmune disorders like rheumatoid arthritis. With its extensive enzymatic functions and antioxidant action, what if vitamin C plays a vital part in staving off chronic disease? Is that why our body expends energy to accumulate vitamin C in almost all our organ tissues? Could that be the reason almost all animals produce it in large amounts in the body, 13,000 milligrams daily for a goat, relative to the RDA of 70 to 90 milligrams we currently believe is enough for people? Without jumping to radical conclusions of a universal cure or panacea, the evidence does seem to indicate that perhaps vitamin C isn't just another micronutrient we only need in small amounts. Perhaps vitamin C is a fundamental molecule with indispensable functions at the cellular level. Could vitamin C also be the key to understanding why there's overwhelming evidence that a diet rich in fruits and vegetables significantly decreases the risk of dying, especially from heart disease and cancer? There's even a recent proposition from John Edgar that because of its roles in stem cell mitotic activation, meiosis, epigenetic regulation, and cellular differentiation, vitamin C or L-ascorbic acid should be considered a critical factor that enabled the evolutionary transition of our single-celled ancestors into multicellular organisms, leading to the extraordinary variety of life we see today. A transition described as a fundamental forbidding evolutionary puzzle that scientists are still scratching their heads over to this day. So is vitamin C merely a vitamin or just another micronutrient? Or could ascorbic acid be an extremely overlooked foundational molecule necessary for a functional, healthy body? The evidence I've laid out here seems to support the latter, and trust me when I say that this is just the tip of the iceberg. If you learned something new from this video, hit like and subscribe.